Hello everyone, this is Dilip. Today let's talk about encryption. So what is encryption? Say you have a plain text data and you modify it in such a manner that the contents of the data will be unreadable or unable to be interpreted. We call it as an encrypted data. So this encryption is required when we are transforming confidential information or any information. If we feel it has to be go through encrypted tunnel, we use the encryption. So there are two main types of encryption. One is symmetric encryption and other one is asymmetric encryption. Symmetric encryption in simple terms, if we use the same key for encryption as well as decryption, we call it symmetric encryption. For example, let's say we have a key K, which is a symmetric encryption key. We have the input data and the encrypted data here. Now, let's take a simple encryption algorithm, which is XORing the input data with the key will give us the encrypted data. So I XOR K is O. Similarly, for decrypting the encrypted data, since we are following symmetric encryption, we have to use the same key. So same key we use for XORing the encrypted data and we will get the input data. So as most of you might already be aware, XORing the same value twice with any given input will result in the same output. So that's the intuition, we'll get the input back. So this is very basic form of example I gave for symmetric encryption, but in practice it is much more complicated. We'll look at it in later videos. Now let's move on. Asymmetric encryption. So here the key is different for encryption and decryption. So we don't use the same key for encryption and decryption. So here always we call key as a pair. So it's a set of keys. One we call private key, other one we call public key. So more details we'll discuss in later videos. But just remember, in asymmetric encryption, a key means always it's a key pair of public and private keys. Now given input data and encrypted data represented with I and O, I XORing with K1. So here also we are assuming our algorithm to be a simple XOR function. So input XORed with K1, it gives output data, and output XORed with K2 will give the input data. Now output XORed with K1 should not give the input data. Input XORed with K2 should not give the output data. So that's the intuition here for asymmetric encryption. These are the key differences between symmetric and asymmetric encryption. In symmetric encryption, we use the same key for both encryption and decryption. Asymmetric encryption, a different key is used for encryption and a different key for decryption. Symmetric encryption is faster. Why we will see in the later videos. Asymmetric encryption is slower. Since symmetric encryption is faster, so any protocol you take, whether it may be TLS or SSH, anywhere. So we initially use the asymmetric encryption since it is more secure to derive the keys and then use those keys for symmetric encryption used for the communication. So always, whether you use the TLS or SSH, even though asymmetric encryption is more secure, we use it only to derive the symmetric encryption keys, and ultimately we use the symmetric encryption only for the data flow. And examples of symmetric encryption are AES, 3DES, etc. And examples of asymmetric encryption are RSA, ECDA, etc. Thanks everyone for watching the video. Bye.